Hi, today I'm going to talk to you a little bit about how we determine the sample size n required when we're trying to estimate a population mean if you know the population standard deviation. So we have these three formulas here that we're going to be using for estimating sample sizes. Remember, what we're estimating is a minimum sample size in order to have a certain level of confidence that our confidence interval, that our population value will land in the confidence interval that we are interested in. So for this particular case, when we have that the population standard deviation is known and we are trying to estimate a population mean, mu, this formula right here, the first of these three formulas, is the one that you will be using. And when you look at this formula, you see that we're going to take the critical value, z alpha over 2, multiply it by sigma and divide by e, and then square the resulting quantity. Or we will just take the critical value, square it, the standard deviation, population standard deviation, square it, and the level of error, e is our margin of error, and square it. And if you take those things and you put them together, you will get the sample size n that you required. So let's look at this example. How many people would you need to randomly select in order to estimate the average income in the state of Florida to within $1,000 at a 90% confidence level, given that sigma is 20,000? The things that we need the critical value, z alpha over 2. You know how to calculate that already. At a 90% confidence level, when you calculate out z alpha over 2, you're going to get that z alpha over 2 is 1.645. That's something that you may have done this enough already that you just know this, or you can go through the calculation for finding the critical value. Sigma, they gave you, it's $20,000. E is your margin of error. When we say to estimate it within a certain value, this is E. E is our margin of error. E is 1,000. So then we're going to put this all together into this formula, and we will get that n equals z alpha over 2, 1.645, and we square that. I'll use this version right here. We multiply it by sigma squared, which is 20,000 squared, and we're going to divide by E, our margin of error, 1,000 squared. And we'll plug this into our calculator, and when we plug this into our calculator, we're going to find that we get 1082.41. So that's the number that you get out of the calculator. But think about it for a second. This is not quite the answer that we want. We want how many people. And you don't work with pieces or portions of a person. Fractions of people don't really make sense. We're trying to find a minimum sample size. So think for a second. How many people would we actually have to ask? You can't round down in this case to 1,082 because that wouldn't give us enough. We need at least this many. So we're going to round this up to our final answer of n equals 1083, 1,083 people. We have to go up. So the rule is when you have this, for this type of problem, when you're determining sample size, you always round up.